Hey everyone, today I want to show you something I've been building over the past few weeks that actually got me pretty excited. I've automated an entire Splunk deployment on Kubernetes, not just the install, but the log onboarding, the hack setup, even the dashboard creation, all driven by plain English prompts through the tool called OpenClaw. But before I show you the demo, I want to explain why I built this in this way. Because there's a really interesting difference between what I'm doing here and just writing an Ansible playbook. Stick around because I think this changes how you think about infrastructure automation. So here's the scenario. You are a cybersecurity engineer. You get a new Kubernetes cluster, whether it's on-prem, micro K8s, EKS, whatever. And you need Splunk running, ingesting logs, and giving you visibility fast. The traditional path looks like this. You write a hem values file, you figure out the hack token setup, you manually curl the Splunk management API to create indexes, you write Splunk queries, you build dashboards by clicking through the UI. Each of these steps require you to know the specific tool, the specific syntax, the specific API endpoint. And if you are doing this for 10 clusters, or if a junior engineer needs to replace it, you are either writing a massive runbook or you are writing Ansible. Now I want to be clear. Ansible runs reliably. It's idempotent, it handles a configuration drift beautifully, but Ansible is fundamentally declarative. You have to know exactly what you want to happen and write every step explicitly. What happens when the Splunk pod crashes during seeding? Your playbook failed at task 14 of 40, and you are reading errors log trying to figure out which handlers to trigger. What if the hack token format change between Splunk versions? You're updating your playbook. The key differences with what I'm building is that the reason layer is separate from the execution layer. I described the outcome I want. Install Splunk on my micro Kubernetes cluster, enable hack, create these indexes with these source types. And the skill figures out the steps, handles errors, retries, and adapts. Think of Ansible as a very precise chef who follows a recipe exactly. OpenClaw skill is like a chef who understands what the dish should taste like and adjust on the fly. So what actually is a skill in OpenClaw? At its core, it's a structured prompt, but with a few powerful additions. A skill has a goal definition. What it's trying to achieve, it has a phases, discrete checkpoints that can succeed, fail, and be retried independently. It has a state. It writes its progress to a state file, so if it gets interrupted at phase 3, it resumes from phase 3, not from the beginning. And it has a verification built in. After each phase, it confirms the outcome before moving forward. Let me show you this live. I'm on a fresh Ubuntu 24.04 virtual machine with micro Kubernetes running. Nothing installed yet. No Splunk, no folder, nothing. I'm going to open OpenClaw and copy the files into a global skill folder. So my Splunk skill has 4 phases. Phase 1 installs Splunk via Helm and waits for the pod to be healthy. Phase 2 enables a hack and creates the token. And phase 3 onboards the initial logs with the correct indexes and source types. Phase 4 deploys the Python logs folder as a systemd service. Each phase is independent. Each one verifies its own success, and if something goes wrong, like the seeder job failing, which absolutely happened to me, it diagnoses and fixes it rather than just dying. Run the prompt in 4 different phases. Now let me switch to the Splunk UI. And you see the events are already flowing. Index equal to main, and then syslog, all with the correct source type indexes. And finally, the new dashboard. That entire setup took several hours, but I didn't touch the Splunk UI, and I didn't hook up a single API endpoint. So the mental model I want you to take away from this is, skill is not replacing Ansible. It's operating at a higher level of abstraction. Ansible is still the right tool when you have a well-defined stable procedures that needs to run identically every time across hundreds of hosts. Skill is the right tool when the procedure involves reasoning, when you need to handle variability, diagnosis failures, and adapt to the actual state of environment rather than the state you expected. It's an AI-powered cybersecurity engineer acting like a person. In the next video, I'm going to show you how I scale this out, onboarding Kubernetes system logs, Kubernetes logs, all with a Fluent bits, and then I'll show you something really cool. Running a prompt that analyzes all of these logs and generates a health report without me writing a single Splunk query. If that sounds useful, hit subscribe and I will see you in part 2. Thank you very much for watching. I'll see you there.